So I'd like to introduce Jim Mandeville. He's a senior project manager for large loss. And Jim's been in the restoration industry for nearly 18 years, specializing in the management of very large and complex manufacturing, commercial, industrial, and mining losses. Jim has been involved in every major Canadian catastrophe since 2003. He holds 3 Master Restorer designations from IICRC and a wide variety of safety-related certifications. Jim's based in the Greater Toronto Area and manages large and complex losses across North America. So Jim, thank you very much. Appreciate you coming on today to do this presentation. And I will put it over to you.
All right. Thanks a lot, Penny. And thank you, everybody, for coming today. We're going to talk a little bit about water damage today, sort of keep it relatively high level, and hopefully there's some things you can pick up on. As Heather and Penny mentioned, if you have any questions, if you'd like to put them in the chat, I will get to them if I catch them, and otherwise we'll do a few questions at the end here, and hopefully we should have lots of time for that. So everybody can see the presentation, I'm sure, so we'll get things moving today. So on the agenda today, talking about water damage, we're going to do an overview. We're going to talk about the categories and classes of water losses, and then sort of walk through at a high level the response to a water loss and how we go through cleaning it up, drying it out, and managing all the documentation that goes along with that. So the IICRC, as Penny mentioned briefly, there is the governing body that basically provides a set of rules and guides for restoration in general, not just water damage, but also fire and mold and a lot of cleaning and maintenance actually in commercial facilities, which some of you may be familiar with. So it's the Institute of Inspection, Cleaning, Restoration, and Certification. And what we're going to focus on today is a document they produce called the S500, which is a standard, professional standard for water damage restoration. This is recognized by ANSI, which is an international governing body. And this standard is widely accepted across North America, Western Europe, Australia, New Zealand, about as close to global as you can get when it comes to water damage. So when I talk about classes and categories of water and rules and why we do things, it's not because this is how Jim does it. It's not that this is how First ONSITE does it. This is the internationally accepted method and the internationally accepted guidelines. So these are, it's the rule book that we all follow in the water damage business. So step one is understanding the categories of water losses. So we divide all water losses or floods or water escapes, whatever terminology you like to use, into 3 basic categories. Now, these categories are determined based on where the water came from and what sort of risk that water poses both to the structure and to human health and occupation. So obviously the 3 basic categories here, 1, 2, and 3. And in layman's terms, which we don't use in the standard anymore, but it's easier to understand, clean water, gray water, and black water. The reason we don't use those terms anymore is they're very deceiving, and you'll see what I'm talking about in a second here. So category 1 water losses, these are probably the most prevalent and the most regularly encountered by facility operators and managers. And this is a water escape that originates from a clean source. And when I mean clean, really what I mean is potable or drinkable. This water does not pose any sort of substantive health risk. And this water normally comes from, again, potable supplies or drinkable supplies. So water supply pipes to things like sinks and tubs and things like that. Overflows of sinks, very common in commercial environments, or leaky sink, leaky taps on sinks, things like that. And really the message here is that it's, about as close to drinkable water as we can get. Category 1 water losses or clean water losses can deteriorate into category 2 or category 3 losses for a number of reasons. So when I say deteriorate, I mean get worse, right? So we have this nice little sink overflow, there's a puddle on the floor, no big deal. We clean that up every day in our house. We clean it up every day at work. But if that water loss then travels from floor to floor, so if your sink overflows on the 3rd floor, goes down to the 2nd floor, now it's passed through all that building material, it's going to deteriorate to a category 2 loss. Same thing if it goes from room to room to room, things have gotten worse, right? any mixing with soils. So even if it's clean water, if it, runs through a big pile of dirt on the floor, it's not clean water anymore, right? I mean, a lot of this seems like common sense, but in the moment when you're ready to deal with it, might not be so common sense. The other really big thing is elapsed time. So sink overflows on, the third floor, stays on the third floor. It's a puddle. Maybe it's got the cabinet a bit wet or the bottom of the wall or something. And we go, I really don't have time to deal with this right now. Let's wait till tomorrow. Well, tomorrow it's a category 2 water loss, and the sort of cleanup measures that are going to be required and the precautions are going to be a lot more than they are today. So time is of the essence, and hours matter when we talk about these things. Category 2 water losses, or losses that start out as category 2. Now, this is water that contains significant contaminants and have the potential to cause sickness or discomfort in people. This can also deteriorate, like I mentioned before, if it lasts for 24 hours. So if the water's sitting, or if it passes through building materials, or mixes with soils, again, if it's a really dirty floor or something like that. So common sources of category 2 water losses, where these things start out. One of the most common is discharge hoses from washing machines and dishwashers. Now, a lot of people say, well, I clean my dishes or I clean my clothes in that machine. How dirty can it be? Well, this is the hose that takes the water after it's done that cleaning. So if I take that hose and I fill a mug up with it, are you going to drink that water? The answer is probably not. It's pretty gross looking. So that's not clean water anymore. It's a category 2 water loss and has to be treated as such. Another very common one in our industry is building operators and managers, discharge from fire suppression systems or sprinkler systems. Anyone who's seen one of these things go off, water's nasty. It is not clean, okay? And we have to treat it as such. Another very common one is seepage through foundations or through the building envelope. So this is water from the exterior of the structure that's penetrated either the foundation or the building envelope, being the walls, doors and windows, or very common ice damming through the roofing system. The reason that's treated as category 2 water is, again, because it's passed through those dirty building materials. So it's no longer clean. Another one, interesting one that's on the slide here is a broken aquarium. I like to call that one category 3 or really dirty water because we all know what the fish are doing in there. So I'll leave it at that. Category 3 water losses. This is water that's grossly unsanitary and potentially contains pathogenic agents such as gram-negative bacteria, viral contaminants. There's also the potential for chemical contaminants. And the reason all those contaminants are in there is, number one, it usually comes from the sewer system. We all know what's in there. Now it's in your building. It's really gross. It's dangerous. It's going to cause a lot of damage. There's going to be a lot of stuff required to clean this up properly. The second most common place this comes from is what's called overland flooding, which is when we have flooding throughout the area of town or the neighborhood, the whole town potentially. Some stuff I was just in where that water carries everything that was on the surface of the earth. So what the dog did on the lawn, what's on the road, all that stuff washes it into the building. Again, very dirty, very hazardous mess. And then, of course, the third place that we can get a category water loss from is something that started out as category 1 or category 2 and got ignored for a number of days or went undiscovered for a number of days. Anytime water sits, and we've all seen this for days or worse, weeks, it gets pretty nasty and it gets pretty dirty, and it really has the potential to cause a lot of health concerns. So this has to be treated very seriously, and health and safety always being number one. We need to be very careful going charging into these things. Building operators are almost always guilty of this. They see water, they see a problem, they go charging into it. And I get it. I mean, at one point was the same. The problem is you go charging into this water in your running shoes, or worse, less than running shoes, and you can get really, really sick. I've seen people get some really nasty bacterial infections. So you really need to stop and take a minute and protect yourself before you get in this. When we clean up category 3 water losses, the personal protective equipment is going to be similar to what you're seeing in the photograph here. So disposable waterproof coverall or Tyvek suit, rubberized safety boots, gloves, and more often than not, full face respirators. The reason we have that respirator is, number one, it helps a little bit with the smell, which I'm sure you can appreciate is unpleasant. But number two is it stops the technicians from touching their face. As we've all learned through COVID, sort of digital ocular contact or hand to eye contact can be a real method of transmission for bacterial contamination or viral contamination. So the full face really helps the guys from touching their face just by accident, not thinking about it. I'm going to do it 57 times while we talk here, probably. And everybody does it. And I think this whole Zoom world has really shown us that this is a real concern. You're also going to see us use a lot of air scrubbers or air filtration devices when we do this sort of cleanup. And what that does is help mitigate any risk for any contaminants that are potentially become aerosolized or airborne during the cleanup process. As I touched on briefly, the time effects on these categories of water are really critical. And the response to any water loss is critical. Hours matter, literally. This thing happens at 5 o'clock and you're trying to go home, or it's your kid's birthday or whatever. You need to deal with it right now. Hopefully that means you can just make a phone call, but at the same time, it needs to be dealt with, because tomorrow it's going to be way more money. It's going to be way more downtime and way more problems. The other thing that's really critical to keep in mind is that the recognized standard is that under ideal conditions, within 48 hours of water exposure to building materials, mold can begin to develop. So if you have this little sink overflow and it seems like no big deal, it's Friday, nobody wants to deal with it, you wait till Monday. By Monday, it may be moldy. When things go moldy, the price skyrockets, the downtime skyrockets, and the amount of effort on your part and everyone's part to get that restored skyrockets as well. So time, and potentially temperature also, the warmer it is in the building, faster mold will grow. Time and temperature are definitely the enemy here, and cranking the heat up is not an answer. So categories of water losses, like we talked about before, is where the water came from and what sort of risk it poses. So now we're going to talk about classes of water damage, and I recognize this is a bit confusing. Category, how dirty it is. Class, how we're going to respond to that loss and how we're going to clean it up. So there are 4 basic classes of water damage restoration, maybe is a better way to put it. So a class 1 water loss is sort of what we've been talking about to date here. It's your sink overflow, it's a puddle on the floor, and really is defined as only impacting a portion of a room or a small area, generally on the floor. Again, you guys clean this up all the time. It's pretty straightforward. Mop the water up, make sure it's dry, sanitize the area, move on, right? No big deal. So class 2 water damage, things have sort of escalated quickly, as they say, and gotten a little bit worse. And this is water that's affected the entire room now. And it started to wick up the walls. So when I say wick up the walls, people say, well, it's just the carpet that's wet. Probably not. Drywall, by its very nature, gypsum wallboard, is a highly desiccated material. So when the water's just along the floor, just along the carpet, as soon as it touches the very bottom of that sheet of gypsum wallboard, it's going to wick up through capillary action, basically, or similar to capillary action. So even though the water is only floor level or the carpet's wet, that moisture will begin to wick up that gypsum wallboard. In fact, the water damage you're seeing in the photograph here, inside 3 or 4 hours, moisture is going to be 6 to 12 inches up that wall every time. And that's going to necessitate having to either dry that out, do some partial removals. There can be any number of things that are required now to clean this up. So generally, once it's got a whole room wet like this and it's gotten to the base of the walls, things are worse, and you're probably going to need some help with cleaning it up. Class 3 water damage losses, this is sort of, things have gotten much worse. And this is definitely where you're going to want to consider engaging a professional to help you work through this process. This is water that, again, it's gotten the whole room wet, normally more than one room, potentially, whole floors of a building, and then it's traveled from floor to floor. So now we have overhead water damage to ceilings, as you see in the photograph. We have walls that are wet from the base all the way to the top, and this necessitates a much higher level of response. So you're definitely going to start to see some selective demolition in these scenarios. You're going to see things opened up. A really key point about ceilings in commercial buildings is what's called the interstitial space. What that is the gap here that's between this ceiling here and the floor above it. Now, inside that interstitial space in most commercial buildings is a lot of mechanical systems. A lot of those mechanical systems have insulation on them that can be impacted by water damage. We can also have spray application fireproofing that's in this area that can be impacted by the water. So this is now a pretty complicated deal to clean up and a fairly complicated issue to repair. So again, if it's gone from floor to floor and room to room to room, this is definitely where you're going to want to consult a professional. Now, Class 4 water damage, this is sort of the specialty bucket. So this is stuff like water damage that affects hardwood floors or multiple layers of wood floors. So as you see in the photograph here, we have some dimensional 3/4 inch T&G maple flooring, potentially on top of plywood, potentially on top of concrete. In some scenarios, if this is a category 1 water loss or clean water, this can be dried and we can make this go flat again, and maybe you can save this. But it requires a lot of specialty equipment. It's going to require a lot of specialty know-how, and it's going to take some time, and it's going to cost money. So, and we'll go through that sort of cost benefit analysis a little bit more detail going forward. But the important part is Class 4 is anything complicated. The other thing that falls in Class 4 is concrete. Concrete's an interesting material where it very readily accepts moisture or soaks water up, and then it really doesn't like to let it go. So getting concrete dry, again, is a very technical process, requires a lot of know-how and specialty equipment. And if you don't get that concrete dry, especially concrete slabs, say in an apartment building, and you go and you install new flooring on it, number one, you're going to have no warranty per the flooring manufacturer if you actually read the details. And number two, that floor is likely not going to properly adhere. So it's really critical that that concrete slab is dry before you install any new flooring material on it, or you're going to end up doing it twice, or worse, more than twice. So concrete, really specialty thing, really difficult to deal with. So we've had our flood, right? The sink's overflowed. It's gotten into a few offices and it's gone floor to floor. Now we're going to talk about water removal and cleanup. So physical removal of the water is always step one. So when I say physical removal, I mean pumping it, squeegeeing it down the hallway and down the stairs, mopping it up, whatever we got to do to physically remove that water from the building. So physical removal of the water, pumping, squeegee, mopping, etc., is up to 1,000 times more efficient than evaporation and structural drying. So for every liter of water we can get out of that building physically, it's going to make the rest of the process that much faster and that much more efficient and minimize your downtime. So we always want to extract as much physical water as we can possible. Once we've done that, then we're going to install a structural drying system. So this can be air movers and dehumidifiers and potentially other pieces of specialty equipment to get the building back down to its equilibrium moisture content and get it dry so that you can then do repairs. So we've got the water out, we're ready to set up our equipment. Generally speaking, with these sort of class 3 water losses where water's gone floor to floor, we're going to have to do some selective demolition. We're going to have to remove some drywall, right? And probably some flooring. Before we can remove any drywall or any ceiling tiles, we need to see your, whatever you've got in your province. In Ontario, it would be called a DSS. In British Columbia, it's called an HMI. In Atlantic Canada, there's a variety of terms for this. Basically, it's a hazardous material inventory for your building. And that's really identifying the things we're really looking for during water damage restoration are asbestos, lead, and potentially mercury. So we need to know before we're cutting that drywall out, whether it's got asbestos in the joint compound, whether there's lead paint present, things like that. If you don't have a hazardous material inventory or survey for your building, as part of your corporate policy, then we'll work with you to get some samples taken and verify that. Again, we need to make sure that these materials are properly and legally handled. Just because we're in a hurry and it's wet doesn't mean we can go breaking the rules. Here's a picture of a super moldy few ceiling tiles for anybody that's interested in these ones. So again, hazardous material identification, right? We're identifying some mold right here. So obviously this is going to have to be treated differently than your standard sort of selective demolition for clean water. It's going to require probably a full-blown abatement, right? Now, when we talk about hazardous material abatement, we've had our flood, we've done our testing or our sampling, or we've consulted your inventory for your building. And unfortunately, we've identified some asbestos in the joint compound. So now we're going to have to conduct an abatement as opposed to just our standard sort of, selective demolition. three major sort of categories of asbestos abatement, which are high, moderate, and low risk procedures. Most of these things are going to look like what you've seen in the past when it comes to abatement: plastic chambers, decontamination chambers, negative air, specialty staff, specialty equipment, all those things. Generally speaking, we're going to have to file some sort of notice with the province, especially if we're doing high risk abatement. The workers who are going to be required to do this, they're skilled, experienced people. You can't just use general laborers or your own staff or our water damage people to do this. Highly skilled and experienced, and generally licensed, depending on the province that you live in, to conduct asbestos abatement. We're also going to help you and work with you to get a third-party environmental consultant who's going to conduct background sampling before, clearance sampling after, and any other sort of air sampling or surface sampling that's required as part of the abatement. And then the other important thing to note with asbestos is that the disposal of asbestos containing material is highly regulated in Canada and generally highly expensive. So it's a lot more money to throw that drywall away if it's got asbestos in it as compared to not having asbestos in it. Now, mold abatement, like the photograph we saw a few minutes ago, similar level 1, 2, and 3 procedures to asbestos abatement. However, mold is not legally regulated in Canada. So the guidelines we go by are generally either ECO or CMHC, or the IICRC also has a set of guidelines for mold abatement. Again, it's very specialized work requiring highly skilled and experienced workers. We're going to have the same environmental consultant involved. It's going to do sampling sort of before and after to verify everything for you. And the real difference here is that disposing of moldy drywall or moldy building materials costs the same as disposing of regular building materials. So the disposal of mold is not regulated at all. There's no additional costs there other than potentially a lot more bags and a lot more effort, because again, we've got to put all the plastic up, negative air, skilled people, etc. So moving forward, if we've had your water loss and we've, checked the DSS or the HMI and done our sampling, and there's no asbestos and there's no mold, best case scenario, right? We can move forward now. So what we're going to consider these are sort of the drivers of whether we're going to remove building materials or try and dry them, save them, and do repairs. What we need to consider, number one, is cost. Okay. Is it going to be cheaper to just cut a whole bunch of drywall out instead of trying to dry it and save it, or vice versa? Depending on your situation, it may go either way. The other driver, obviously, is health and safety. If it's a category 2 water loss or a category 3 water loss, the vast majority of those wet building materials are going to end up needing to be removed. Porous building materials. Things like metal framing, as you see in the photograph here, can almost always be cleaned and saved. Ceramic tile floors, like in the photograph, as you can see, can always be cleaned and saved. And then the other thing we're going to consider is downtime. So depending on the nature of your business or the occupants, maybe time is going to outweigh cost, and we just need to be open, even if it's going to cost a bit more money. And that's going to help drive our decision making as to whether we're going to remove something or we're going to try and save it, and sanitize it and clean it and everything else. The science of drying has come a long way in the last sort of 25 years. We can dry and save almost anything if it's safe to do so. The question is again, is it worth it time-wise? Is it worth it from a monetary perspective? Or potentially, is there some sort of historical or sentimentality attached to it? If we're working in a historic building, obviously a lot more effort's going to be put into saving building finishes than if it's just, as you see in the photograph here, this is just an institutional building with regular painted drywall on the walls, right? There's no sentimentality attached to that at all. Now, I talked about water wicking up the drywall before when just the floor is wet. So for reference, the water loss that occurred in this building you're seeing in the photograph here, the water was only about 2 or 3 inches deep throughout this building. Unfortunately, it was overland flooding. So it's a category 3 water loss, really dirty water. And as you can see, we had to cut, between 2 and 4 feet of drywall out of this whole building. And that's because that water had sat for a number of days before we could access it, and it wicked up the drywall and really caused a big nasty mess. So definitely a lot of drivers as to why we're cleaning and why we're saving something or why we're not. And that should be an active discussion between the restoration professional and yourselves as building operators and managers. So cleaning and sanitizing. So we do our selective demolition, and then we're going to do a really thorough cleaning and sanitization of the whole area to kill anything that may be left behind. This is bacteria we're talking about, viruses, anything like that. We want to make sure all that bad stuff is gone. Now, what I missed a little bit earlier on is right after we do our water extraction, we're also likely going to lay down a coat of sanitizer at that point as well. The reason we do that and the reason we sanitize more than once, and on really nasty sort of sewer backup losses, we may do this 3 or 4 times. The reason we're doing this is we're trying to reduce what's called the bacterial load on the project. So the amount of gross bacteria that's in the building. Every time we lay down a coat of sanitizer, it's killing more of it. A lot of times, especially when it's really nasty, one application isn't enough to kill it all. So a lot of times we're going to do this more than once. On clean water losses, maybe only once, but category 2 and category 3 water losses generally 2 or 3 times. We're going to use a variety of different sanitizing agents to make safe your building, ranging from biologicals to botanicals. Most of what we use are today, 90+% are botanical disinfectants, like you see in the photograph here. I'm not plugging a specific brand. There are many brands out there. We also use biologicals or enzyme-based products to help break down things to do with proteins, specifically sewage. I'll let you do the math on the chemistry there. There are a lot of chemical disinfectants out there, as of course you guys are very well aware. We try and avoid them. Don't like to use quaternary ammonias, don't like to use potent chlorine-based disinfectants for a number of reasons. Number one, it's too hard on our staff and it's too hard on the environment. So the botanicals have come a long way. They're very effective. The kill claims are very good. And they're almost harmless, very close to neutral pH. The PPE requirement is relatively minimal. Storage and transportation is easy. Whereas with quaternary ammonias, especially, the PPE requirement can be very high, can cause a lot of environmental damage if it gets into the water stream. And with chlorines, we can have secondary damage to things like furniture or other soft metals and fabrics and things like that. So, as an organization, we're always going to focus on botanical disinfectants and sanitizing agents, as well as biologicals, and avoid those harsh chemicals. So we've got the water extracted. We've got the building sort of clean and sanitized. We've done our selective demolition, removed the wet drywall we need to remove probably a lot of flooring that needs to be removed. Now we're going to talk about returning the building to what's called equilibrium moisture content, or dry. So dry is sort of a deceiving thing, because there's no such, well, there is a such thing, but in nature, there's almost no such thing as absolutely dry or 0% moisture content. So what we're trying to get it down to is its ambient or its normal environmental condition. We're going to do that by using a variety of equipment. Some examples you can see here. So when we do our initial extraction, we're going to use water extraction machines, or as you may be familiar with them, portable carpet cleaning or hot water extraction units. They're very, very good at cleaning up floods. A lot of the ones we use are a little more specialized towards flood cleanup, where they continuously pump themselves out instead of just relying on that, whatever it is, 3-gallon or 4-gallon tank in the machine. But your regular carpet cleaning machine, if you're cleaning some up yourself, it'll work great. Also going to use a variety of pumps, obviously, if there's some depth to the water. We're going to use some air moving equipment. We're going to use centrifugal air movers, which are the sort of standard snail type air mover, like you're familiar with. The carpet cleaners have used them for 40 years. I'm sure a lot of you potentially have a couple of them in your buildings that you use even after you've mopped a big floor. And then what we're using a lot of today are called axial air movers, which you can see in the photograph here. It's a big round one. I like these a lot better. They get a lot more airflow out of them. The electricity draw is less, so it makes it easier for us to install the equipment. And they're a lot easier to handle and transport because they stack. So you're going to see a lot of those when we're doing a water loss cleanup for you. Also, we're going to use a variety of air filtration devices or air scrubbers, like I mentioned before. These are HEPA filtered air filtration devices to help remove any contaminants that may have been aerosolized during the restoration process, dust, bacteria, or anything else, drywall debris potentially from demolition. So we're going to use a variety of that air moving equipment. Then when it comes to dehumidification, or the removal of water from the air, there are 3 main types of dehumidifiers that are used in water damage. conventional refrigerants, low grain refrigerants, or LGRs, you'll hear a lot of people say, myself included. And then finally, desiccants. We're not going to talk a lot about desiccants today and how they work and everything else. It's a little bit complex. Needless to say, if someone's saying you need one, you're in big trouble because generally it's a really big job. Desiccants come in sizes up to and including tractor trailer size, to put it as simply as I can. So these are usually left for very large jobs or very complex concrete drying projects. In certain scenarios, we're going to use heat. The reason there's a bunch of asterisks here on heating equipment is that if heat is misapplied during a water damage restoration project, in other words, if it's not very carefully managed in conjunction with airflow, you can actually cause a giant mold bloom where the whole place will go moldy. So you got to be really, really careful applying heat. Closing the door in a wet room with a heater with no airflow is going to make it moldy. It's not going to dry the room out. So heat, we have to be very careful with. Talk a little bit more about dehumidifiers. As I mentioned, standard refrigerants versus low grain refrigerant dehumidifiers. So these standard refrigerants like the Stryes 1200 here is basically all we had when I started in the business. We don't generally use them anymore. The reason we don't use them is they don't function very well in cool temperatures. At 68 degrees, about 19 centigrade. A lot of times when we're doing this work, we've had to remove some insulation from the walls. It's cold in the room, not freezing, but cold. So these don't work. They also don't provide very dry air. I'm looking for air coming out of that machine that's sort of, 30 to 35 grains per pound, which is a measure of how much water's still in it. And that's going to help me get that building really dry, and these just don't do it. Now, a real key factor, if you're going down to your local rental center, Battlefield or Hertz or whatever you got in your town and you're renting dehumidifiers, this is what you're going to get, is these standard refrigerant dehumidifiers. Low grain refrigerants is what all professional water restorers are using now or should be using. These are a lot more efficient units. They remove a lot more air sort of per hour from a lot more moisture, per hour from the air. And they also make that air a lot drier when they're coming out the other end. These things are really, the technology is really moving forward quickly on these. They draw a lot less power than they used to, quieter than they used to be, and they remove a lot more water. So professional water restorers are always going to use these low grain refrigerants in today's day and age. Again, to talk about air movers a little bit, axials versus centrifugals. I touched on this before. Centrifugal, your snail style air mover, really good directional airflow, but doesn't move as much volume of air. Axials moves a lot more volume of air, but a lower static pressure, lower sort of directional force. But again, very versatile, lower electricity draw, easier to carry for those of us who've had to carry them. So this is the drying process in a nutshell. And I think if you could take anything away from this, I think this probably adds the most value. So the very nature of our problem here is we have a building material, let's call it a 2x4, that has moisture or water that's bound in it. It's stuck in there. So we've got liquid water in between those wood fibers in that 2x4, and we want to get that water out of the 2x4 into the air, and then out of the air and out of the building. We want the water out. It's the name of the game. So how we're going to do that is we're going to blow air across that 2x4 with an air mover, like we see in the photograph here. What that air is going to do is it's going to add heat or heat energy and allow that moisture in the wood to change state from a liquid to a gas and evaporate up into the air. So very similar principle to when you put your arm out the window of the car and it feels cooler. The reason it feels cooler is there's moisture evaporating out of your arm into the air, and that lack of heat that was required for that change of state of the water has now made your arm feel cooler. So that evaporation out of that 2x4 is also going to make the 2x4 slightly cooler. Interesting fact that we'll get to in a minute. But that water is now leaving the 2x4 and going up in the air in the room. So now we've got the water up in the air. Now we need to get the water out of the room. So what we're going to do is we're going to suck that air through the dehumidifier, and through condensation, that dehumidifier is going to strain, for lack of a better term, the water out of the air and into the tank in the machine. Then the machine's going to pump out the water in the tank. It's down in the bottom here, down a little hose and down the drain, and therefore out of the building. Then out of the back of the dehumidifier is going to come hot, dry air. That hot, dry air goes back in the room. The air mover blows the hot, dry air across the 2x4, evaporation, dehumidification, cycle continues. This is how structural drying works, or drying really of anything works. When it comes to a 6-foot puddle on the floor in an office, to drying out 700 hotel rooms across 40 floors, the principle is the same. Nothing changes. The only thing that changes is the number of pieces of equipment and the different ways that we manipulate the air currents in the building. So this is really the name of the game, and what we're doing and why we need all that equipment and why it's making a noise is to get that water out of the building. So when we're setting up drying equipment, it's a little interesting facts here. Air movers are almost always going to be set at a 45-degree angle to the wall. What that's doing is maximizing the velocity of air against the wall, which is maximizing evaporation. Because again, generally we're trying to get water to come out of this drywall here along the wall. What it's also doing is they're also all going to be pointed in one direction. And that helps us create a vortex, or again, increased airflow around the perimeter of the room, and really helps speed evaporation and maximize evaporation. Then you're going to see dehumidifiers in the room. In this photograph, it's the silver one here. They can kind of go anywhere in the room. Because that dehumidifier is treating the air in the room, it doesn't really matter whether it's 6 feet to the right, 6 feet to the left, by Joe's desk, by Sally's desk. It doesn't matter. Generally, we're going to put it somewhere that's close to a plug. We're going to put it somewhere that's close to a drain, because again, these have a hose on them to pump the unit out and empty that water down into the sink. And we're also going to avoid putting it on any sort of really sensitive flooring in case there's a leak or a mishap with the machine. So we're generally going to try not to put it on hardwood floors. If we have to, we have these trays for them, sort of emergency trays in case they do leak or something like that. They're also going to be placed equidistant across a larger room. So if we've got a big, bullpen style office, we're going to spread these out throughout that large area. And the dehumidifiers are sized as per sort of the cubic footage of the room, just as a point of fact. So while we're doing this structural drying, you're going to notice that a couple of our technicians are going to be around after setup, taking a whole bunch of notes. Now, this is a bit of an older form, but it's easier to explain. A lot of this is done on our tablets now, but we're going to be recording a lot of data during the setup and then during the drying process. The reason we're going to do that is it's going to create a daily record of the drying process from the start to the finish to prove that, yes, indeed, the building was wet. We made it drier each day, and now it's dry at the end. And we do that so we can provide you those records in case you have any disagreements with tenants or occupants, potentially employees or unions. This provides a very valuable record that you can provide to them to say, look, we had a water loss, we hired a professional, and they mitigated it as per the internationally accepted standards, and here's all their records. This can be really important, down the road for a simple bit of time for us to do that for you. So the techs are going to come back every day. They're going to take more measurements. Now, what you can see in the slide here is the amount of data that's been collected on this piece of paper in the picture. This is the amount of data we would collect for a puddle on a kitchen floor over 3 days. So if you think about a flood that's now affected 15 apartments, there's 4 or 5 rooms in each apartment. So that's 4 or 5 of these per apartment times 15 times maybe 4 or 5 days to get it dry. That's how much data we're collecting. It's a lot. We're collecting things like the temperature and relative humidity in the room, specific humidity in the room, the performance of the dehumidifiers, as well as moisture content and materials. So a lot of data that's being collected. Now, to collect that data, we're going to use a variety of instruments to measure moisture levels, both in the air and in the building materials. So when we're measuring the air, we're going to use something called a thermohygrometer. This is a multifunction meter that measures things like dry and wet bulb temperature, relative humidity, specific humidity, which is GPP in the slide here. And that's specifically how much water's in the air. Problem with relative humidity, like you hear on the news, and this is a bit of a tangent, is that it's relative to temperature. So when somebody says you have to keep the humidity in your building between 30 and 50%, that 30 and 50% is relative to the temperature. So 30% humidity at 26 degrees centigrade is really, really dry, actually. But 30% humidity at 8 degrees centigrade is really, really humid. So it's a very deceiving number. And as professional restorers, we want to know actually how much water is in the air in the room. And we use a measurement called specific humidity, or grains per pound, which is an imperial measurement of how much physical water is in that room. I won't get into the math, but that's the difference between the two. We're also then going to use a variety of moisture meters to detect moisture in building materials. So these are, generally speaking, conductivity based, either penetrating or non-penetrating moisture meters that we're going to use. These penetrating ones are the ones with the pins on the end. Non-penetrating usually have some pads on the back. So when we create these drying records, like I talked about, it's really critical that we're taking moisture content and material readings, or how wet the drywall or the the wood framing is, or the concrete, whatever it is we're trying to dry. So we're going to notate the location and the type of materials when we took the readings. And then what we're going to do is we're going to locate a portion of your building that was never affected by the flood. And the reason we're going to do that is we want to know what the normal or background or ambient moisture content of those materials are. Drywall, for instance, in Moncton in the summertime is potentially going to have a moisture content in the neighborhood of 10 to 12%. That's going to be dry or ambient before the flood. That same drywall in downtown Calgary in the summertime is very likely going to have an ambient moisture content closer to 6 or 7%. So there's no magic number for dry, and a lot of things can influence that, from potentially shadows from another building on your building, sun exposure, the performance of the HVAC system, the performance of your windows and doors, a lot of things that can influence ambient moisture content. So we're always going to take those background readings to establish what is dry for your building at that time of year. And then we're going to try and get the impacted or wet materials back to that ambient moisture content through the drying process and the restoration process like we've talked about. When we talk about thermal imaging, and everybody wants to talk about this, it's sort of the new interesting thing for a lot of people in building management, and for us in restoration as well. The price of these things has come way down, so everybody's really interested in them now. I mean, I can tell you, when the company that I worked for bought our first one in the very early 2000s, it was $31,000. It didn't work real great, but man, it was a huge leap then. You buy these things now for a couple of grand for a really good one. You can buy a crappy one that doesn't work very well from a retail store for 300 or 400. Now, the really important thing about thermal imaging is that it's exactly what it's called, thermal. So it sees temperature. You cannot see water or moisture with thermal imaging. You cannot. It's physically impossible. What we as restorers look for with thermal imaging is what's called evaporative cooling. So when I talked about the drying cycle before, when water changes state from a liquid into a gas, when it evaporates, it consumes heat in that process and therefore creates a cold spot. So what we're seeing with thermal imaging is actually hot and cold spots, or hot and cold building materials. As you see in the photograph here, we've got some cold areas around a pot light, got a cold area in the corner. Now, it's entirely possible that this is water, that this is from a flood. It's also entirely possible that this is the winter time and there's some insulation voids in this area of the building, and that's causing those areas to be colder than the surrounding areas. So this technology really needs to be used with a critical eye and with a lot of other training involved. Just pointing at the wall and looking for dark spots, it could be showing any number of things. You could have a plumbing line that's close to the surface of that drywall. You could have a piece of ductwork that's close to the surface of that drywall that's causing it to be hotter or colder, or especially, like I said, missing insulation. As you can see in the photograph here, the vertical lines above the cabinets, those are wood studs in the wall. It doesn't mean they're wet. It just means they're colder because we have heat or cold transmission, I guess is a better way of putting it, from the exterior through that stud, because it doesn't have the same insulatory value as the insulation in the cavities between the studs. So can be a very helpful tool. And really for us, what we use it for is initially surveying a loss. So especially when we have water damage that's, throughout, like I said, 15 apartments, we can now scan through those 15 apartments in, a few minutes to an hour and get a really good idea about what is probably wet and what's probably not in that few minutes to an hour, as opposed to what would potentially have taken hours or a whole day to really diagnose before thermal imaging. So like I said, not the be all and end all, very good survey tool, very useful for electrical work in some scenarios and heat loss especially, but not the be all and end all, and definitely needs to be used in conjunction with some additional training and knowledge and experience. So as a bit of a reminder, training and retraining is critical. Now it's critical for our staff in the water damage business. It's also critical for you guys as building owners and managers. The more you can educate yourself on these things that can go wrong with your building, the more prepared you can be and the more efficient and effective your response can be. Like I said before, hours matter when it comes to water damage. Leaving things wet for the weekend, leaving things wet for overnight, it's going to cost you exponentially more money. It's going to cost you exponentially more time to get that cleaned up and made safe again for your tenants. And that time sometimes is critical depending if you, on who those tenants are. Knowing your building, also critical. I can't tell you how many times in the middle of the night I've run up and down the stairs in a high-rise building looking for a shut off for a pipe because that pipe's shooting water all over somebody's apartment. Again, in these scenarios, minutes matter. You need to know where all the shutoffs are in your building, how to turn the water off. And also, you know, when you call somebody like me to come and help you clean that up, you need to know your building because I'm going to ask you questions like, how big is it? And what's really helpful for us to know is square footage, rough square footage even, how many floors, and also things like where can we park our trucks? Where can we put a dumpster? So really knowing and understanding your building, really critical and really helpful, and will make everything go a lot faster once you know, once these things do happen. Now, documenting your procedures and keeping everything up to date is also critical. As the building manager, you know, often you're the sort of the keys to the kingdom here, and you're going to know, you know, what we do when there's a flood, what we do when there's a break and enter, what we do when something bad happens. You know that you've got that process. But if that's not drilled down to everybody who works on every shift, you're going to have a real, you know, a fatal flaw in your response here. As we know, floods and fires and bad stuff, it never happens on Tuesday at 1 p.m. It happens on Christmas Eve. It happens in the middle of the night. It happens on Canada Day long weekend. So it's critical that those procedures are up to date and that they're drilled down to everybody who might be working, whether that be a, you know, a nighttime maintenance person or a security guard or concierge. They need to know what to do and who to call, and those numbers have got to be good. Again, I've walked into buildings that have had, you know, major damage over at night, and you know, they've called us because they found us on Google. And I get there and I say, you know, well, who are you supposed to call? And they get a binder out and it's got a business card in there and a response plan from 1997. And that phone number and that company don't even exist anymore. That's not going to help you. These things have got to be up to date. You're really going to cause yourself a lot of problems. And again, part of keeping those procedures up to date and well documented is having a trusted partner in the restoration industry that can help you work through these solutions and get you back in business as fast as possible. Again, downtime is key and time is key to getting you back in operation. So again, you can't escape the responsibility tomorrow by evading it today. So the more planning and procedures you can put in place now, the more often you exercise it, the easier all this will be for you. So with that, I can open it up to questions. If anybody's got any, I'm happy to answer them, or comments or anything you want to talk about in the water damage or the restoration business. I'm happy to help you. Yeah, we can definitely get a copy out to everybody, I think, when we're done.
Yeah, absolutely. I can't get my video on, so I apologize. But yeah, we could definitely, the session, as we mentioned at the beginning, was recorded. So just reach out to myself or Jim as well, and I can be sure to get you over a copy of the session. I'll give it another minute just to see. I think another one came through. I didn't have any additional questions either from registration. Penny, was there anything additional that you wanted to add, or I just want to make sure that there wasn't anything there?
Yeah, I don't think so. It was more so for Jim to get the information about water damage to help everybody out, to understand what restoration companies do and why they do it, and to know that we're always here to help them as well.
Yeah, no, a lot of great information, I think, to take away from this presentation today. So a big thank you to Jim. Really, really great job. This was really, really interesting. So, and a great reminder, I think, for all of us, especially around the building maintenance on this. So again, Penny and both Penny and Jim, thanks for working with us and hosting today. We really appreciate your time. If you do get off the call and you have some additional questions, please don't hesitate to reach out. I'll be sure to send your information to Jim and Penny, and they can definitely get back to you as soon as possible.
Heather, there is another question on here.
Okay.
Is there any guideline for the roof leakages?
Yeah, so roof leakage, would be governed the same as any other sort of water damage. So when the water comes in through the roof, we're going to treat that as a category 2 water loss because it's penetrated all those building materials, assuming we catch it the same day. And then we're going to, potentially have to do some selective demolition and cleaning and everything else. But the really critical factor here is you need to stop the water coming in first. So engaging a roofer immediately is always step one. We can also help you with that or any restoration provider can help you with that as well. And then once the water stopped, then we got to look at mitigating the water damage, just like any other category 2 class 3 water loss.
Does that answer your question?
Yeah, out of the chat. Perfect. Any more questions? Give it a second there. See if there's any, I don't want to miss anything.
See, that's it.
I think that's it. Okay, we won't keep you too much longer. Again, thank you, Jim and Penny. We really appreciate it. And we'll be sure to also get the presentation on our member portal for our members that are online today as well. Just a reminder of that. And I hope everyone enjoys their week.
Thanks, Heather. Thanks, Jim. Appreciate it.
Thanks, everyone. Appreciate your time today.